Hello everyone. This is in continuation of various problems what we are doing in normal distribution. Now we are into question number 4. So there is a table being given. Some survey is done on cars and this class interval, we don't know exactly what it is, but some class interval, and they had given us the interval of each range 0 to 0.49, 0.5 to 0.99. Likewise, they gave us the last class interval as 2.5 to 2.99. And then for each class, they also gave us the frequency of each of the class. Total frequency to be 52. This total frequency can be written as we can write the total frequency denoted by capital N, right? What is the question? Calculate the variance and standard deviation of this particular distribution. Then second question is, how many of the observations should theoretically fall between 0.7 and 1.8 if the distribution is bell-shaped? When they say bell-shaped, it's nothing but normal distribution, right? So this is the question. Let us proceed now. Okay, what I did, I simply wrote the same table, this table. Just I transposed the columns to rows and rows to columns. And then the third column, I just wrote down mid-value because the question is asking us to find out variance and standard deviation. If I have to find out, then I need to definitely find out the arithmetic mean. So for finding arithmetic mean, we need the middle value of each. That is what is written there. Middle value, how did I found? I just added these two, 0 plus 0.49. Whatever is the sum, I divided by 2. Similarly, here it is 0.5 plus 0.99. Whatever is the result, that I am dividing it by 2. Likewise, all these things. The last one is 2.5 plus 2.99. Whatever result you get, divided by 2 to get this middle value. Then, since all these numbers are little complex, I can think about doing a step deviation method to find out the variance or standard deviation or arithmetic mean. So for step deviation method, I am taking this is called as origin. Whatever I'm subtracting, that you call it as a origin. Whatever I'm dividing, it is called as a scale. So I am choosing an origin. Generally, origin is chosen in some of these values. Any of these values you can choose. It is preferable if you choose something in the middle. Since there are 6 observations here, exactly there is no middle. So either you choose this 1.245 or you can choose this 1.745. So that will enable you to simplify the numbers. That is what the idea behind all this step deviation method is, to simplify the numbers, right? I had chosen 1.245 as the origin. And it is very clear that all these numbers are divisible by 0.5. So that is the reason I divided it by 0.5. So to make, ultimately the idea is to, how do you simplify the numbers? Now, first one, 0.245 minus 1.245. If I subtract it, you will get what? You will get negative 1. Negative 1 divided by 0.5, that will lead to minus 2. The first value will be minus 2. Likewise, you do it for rest. 0.745 minus 1.245, you will get minus 0.5. Minus 0.5 divided by 0.5, you will get 1. Likewise, the other values 1, 0, 1, 2, 3. You may verify subsequently how these values, same logic, you just substitute the x value here, calculate it, you will get these values. I am considering these variables as now y. Now, I can find out like this. Means, let me find out the, instead of finding variance of x, I'm going to find out variance of y and arithmetic mean of y. Arithmetic mean of y is nothing but summation of fy divided by capital N, right? So that we have to do. Then second, this thing is standard deviation of y. Standard deviation of y means it is square root of summation fy square divided by capital N minus y bar the whole square. The question also asks us to find out variance. So first we will find out variance, then we will take a square root of that to find out what is the standard deviation. So we will, I'm sorry, I should not incorporate this square root because it is variance. So without square root, the same formula. fy square divided by n minus y bar the whole square. So that means we need summation fy, we need summation fy square. So let us do that in the table. Fy, first value, it is 2 into minus 2. 2 into minus 2 is minus 4, then minus 14. Next one will be 0, then 7, then 4 into 2, 8, 2 into 3, 6. Then this total will be 3. F into y into y square means fy already we have. If I multiply this with y, I will get f into y square. So minus 2 into minus 4, it is positive 8. This will be 14. This will be 0. This will be 7. This is 16. This is 18. Sum of this is 63. So we have all these values. Let us substitute the values. Means sigma fy is 3. So here we have 3 divided by capital N. We know it is 52. Let's keep it as it is, that value of y bar. Let us substitute now fy square. Sigma fy square is 63. Let me substitute that here. Divided by 52 minus y bar square. Y bar square is nothing but 3 by 52 the whole square. So if we calculate this, how much do we get? It is 63. Let us directly substitute. Sorry, let me erase that. First, let me calculate 63 by 52. It is 1.21 and then 1.5 minus 3 by 52. Whatever result we get, that we are going to square it. That we will have 0.0033. Now let us subtract these two. 1.2115. We will have 1.2115. Same thing only we get. So this is our variance. Variance of y. So standard deviation of y will be square root of that. Square root of this is 1.2115. Square root is 1.11. Let us keep 1.11 only. Right. Now we have certain properties. We will use those properties. I mean, here they are asking us to find for x, not y is the one variable what we introduced. This variable was not in the original question, but variable originally was x only. So we have to find actually standard deviation of x. So if we have, if let us say, if we have y equal to a plus bx, then I can say standard deviation of y is nothing but, as a property of measures of dispersion, we can say modulus of b times standard deviation of x. So in this case, what is our y? Y is x minus 1.245. So I will write here, y is equal to x minus 1. Let me keep this separately. This property will be using it to find out what is standard deviation of x. 1.245 divided by 0.5. So now this is, I can split it 1 by 0.5 times x minus, what is 1.245? 1.245 divided by 0.5. If I do that, it is 2.49. I mean, I'm dividing this 1.245 divided by 0.5. So I can rewrite this as y equal to a. A means a number without the variable. So that is this negative 2.49. Negative 2.49 plus b times. What is b here? It is 0.1 by 0.5 times x. So this is our b. I mean, this negative 2.49 is our b, and this 1 divided by 0.5 is our, I'm sorry, negative 2.49 is our a, and 1 by 0.5 is our b. So I can simply say this is our A, this is our B. So therefore we can say sigma y equal to what? It is modulus of B times modulus of 1 by zero point 0.5 times sigma x. We already obtained the sigma y. Sigma y is 1.1. That means 1.1 is equal to, what is 1 divided by 0.5? 1 divided by 0.5 is 2 times sigma x. That means our sigma x is 1.1 divided by 2. How much it is? 1.1 divided by 2. We have 0.55. So that will be our standard deviation of x. This is first part of the question. We have done it. Now we have to move into the second part of the question. What is the second part of the question says? If how many of the observations should theoretically fall between 0.7 and 1.8? That means we need to find out what is the probability that x lies between 0.7 and 1.8. Again, let z equal to x minus mu by sigma. So let's do that. Probability of 0.7 minus mu divided by sigma, and then, sorry, one more thing also we have to do. One more property. If y equal to a plus bx, then there is a property for measures of central tendency which says y bar will be a plus b times x bar. So let us use this and find out what is x bar in the next slide. So let me write it here. What is our y bar we obtained? 3 by 52. So 3 by 52 is equal to, what is our A? Minus 2.49 plus B times. So what is B? B is 2, right? Plus 2 times x bar, right? So we can find out what is x bar from this. So let me write it somewhere here. This will follow normal 0, 1. Let us keep this aside because we need x bar also. That is the reason I'm doing now. Let me just put star here. Write that here. What is this? 3 by 52. 3 by 52 is 0.06, and then bring this negative 2.49 to the left side. It will become positive 2.49 is equal to 2 times x bar. If you add these two, 0.06 plus 2.49 and then divide it by 2, we have x bar will be 1.275. Or I can round it off to, because this is what? This is 3 divided by 52. Actually speaking, it is, let me fully write that, 5.8. I can put it as 5.8. 5.8. So this approximately will work out to only this much. Let me write that. This is approximately equal to 1.27. Now, okay, let me come back here. X minus mu by sigma less than 1.8 minus mu by sigma. Mu is nothing but arithmetic mean. This I can substitute, right? And anyway, we already got the standard deviation of x, which is 0.55. Let me substitute those. This will be equal to what? This is equal to probability of 0.7 minus 1.27 divided by 0.55 less than z less than 1.8 minus 1.27 divided by 0.55. If you evaluate all those, we get this is equal to probability of negative 1.04 less than z less than 0.96. So the curve will look like this. This is negative infinity, positive infinity. Negative 1.04 will be somewhere here. Positive 0.96 will be somewhere here. We need this area. So we can split this as probability of negative 1.04 less than z less than or equal to 0 plus probability of 0 less than z less than 0.96. This symmetry, applying symmetry, negative 1.04 to 0 will be the same as 0 to positive 1.04. One and the same, and this will be this. Now for z value of 1.04 and 0.96, we can get the probability value from the table, which will be the first one, 1.04, the table value is 0.3508. And for this 0.96, the table value is 0.3315. From where I got from tables, these two values. So the total will be 0.6823. Therefore, number of observations theoretically between 0.7 and 1.8 will be capital N. Capital N, we know it is 52. And then the probability just now we calculated it is 0.6823. So if I multiply these two, I will get approximately 36 observations. So that is the solution for this particular problem. So in case if you find the contents to be useful to you, I request you to please like, share, and subscribe to my channel. In the meantime, thank you all for watching this video. See you again in the next video. Thank you.